Hello and welcome to today's lesson on dwarf planets. Today we will first describe the key characteristics of dwarf planets, including their size, shape and orbital paths, and explain how these features differentiate them from classical planets. We will then identify and discuss the specific characteristics of Pluto and Ceres as examples of dwarf planets. So far we've explored planets. You have learned about the definition of a planet, the differences between inner and outer planets, and some of the key characteristics of planets in our solar system. Building on this foundation, we can now delve into the intriguing concept of dwarf planets. Understanding dwarf planets will enhance our comprehension of celestial bodies and their characteristics, broadening our overall grasp of space physics. Let's get started. Dwarf planets are fascinating celestial bodies that share some similarities with the classical planets, but also have key differences. Let's explore what makes a dwarf planet distinct. Firstly, size and orbit. Dwarf planets are significantly smaller than the 8 classical planets, such as Earth, Mars, or Jupiter. While they are smaller in size, dwarf planets still share an important characteristic with the classical planets. They orbit the Sun. However, because of their smaller size, they lack the same gravitational influence that the larger planets have. One of the interesting features of dwarf planets is their shape. Despite their relatively small size, dwarf planets have enough mass for their gravity to pull them into a roughly spherical shape. This happens because as a dwarf planet forms, its gravity pulls material toward its center, smoothing out any irregularities and giving it a shape that resembles a ball. This is the same reason why larger planets are round, but dwarf planets achieve this on a smaller scale. A key difference between dwarf planets and classical planets is their orbital paths. While classical planets like Earth have cleared their orbits of other debris, meaning there are no other large objects sharing their path around the Sun, dwarf planets haven't done this. Their orbits remain cluttered with other objects such as asteroids, comets, and smaller celestial bodies. This means that as dwarf planets travel around the Sun, they do so in a more crowded environment compared to the classical planets. These differences are important because they help astronomers classify and understand the diverse range of objects in our solar system. The classification of dwarf planets was established to differentiate them from the classical planets based on their size, shape, and the characteristics of their orbits. For example, Pluto, discovered in 1930, was originally classified as the 9th planet in our solar system. However, in 2006, it was reclassified as a dwarf planet. This reclassification was mainly due to the fact that it does not clear its orbital path of debris. It shares its orbit with other objects in the Kuiper belt, a region beyond Neptune filled with icy bodies. Pluto, like several classical planets, has several moons, with the most notable one being Charon. Charon is quite large relative to Pluto, and together they form a unique system where both objects orbit a common center of gravity. Ceres is another intriguing dwarf planet, with some unique aspects. Unlike Pluto, which is located in the outer regions of the solar system, Ceres is found much closer to the inner solar system. It is the largest object in the asteroid belt, situated between Mars and Jupiter. Like Pluto, Ceres was also classified as a dwarf planet in 2006. Before this classification, it was considered one of the largest asteroids in the asteroid belt. Ceres is notable for being the only dwarf planet located in the inner part of our solar system. This makes it more accessible for space missions and scientific studies. In summary, dwarf planets are smaller than the 8 classical planets, have enough mass to be nearly spherical, but have not cleared their orbits of other debris. Pluto and Ceres are prime examples, each with their own unique characteristics and positions within the solar system. Understanding these celestial bodies helps us expand our knowledge of the diverse objects that exist within our solar system. In today's lesson, we delved into the concept of dwarf planets within the context of space physics. You learned that dwarf planets, unlike the 8 classical planets, are smaller celestial bodies that orbit the Sun and have enough mass to form a roughly spherical shape. However, they have not cleared their orbital paths of debris. We examined examples like Pluto, which was reclassified as a dwarf planet in 2006 and is located in the Kuiper belt with its notable moon, Charon. Additionally, we discussed Ceres, the largest object in the asteroid belt between Mars and Jupiter, and uniquely classified as a dwarf planet in the inner solar system. This lesson has enhanced our understanding of the variety and characteristics of celestial bodies within our solar system, broadening our knowledge of space physics. Watch the rest of the GCSE physics course at Sophos Education.